2.2 is Elements and Compounds from Chapter 2 of our Science Connect 1 textbook. Everything around us, including our bodies themselves, are made out of elements and compounds. So it's important that we learn what the difference is and how these are related. So remember, in our first chapter, we talked about what is matter. Matter has mass, takes up space. We can classify matter as a pure substance or a mixture. So a pure substance is made out of only one thing, whereas a mixture has multiple. We're going to look at a pure substance today, so we won't be worried so much about mixtures right now. So we're going to look at pure substances, and we're going to specifically look at the difference between an element and a compound. If you look at the diagrams here, you can see that an element is made out of only one thing repeating throughout. And it's just a singular, in this case, a sphere. When we look at a compound, though, it looks like it is made out of two different things. In this case, we have something that's gray and something that is red. And for every one of our compounds here, it looks like we have two red for every one gray. I can see that in these cases here. Now, when I look at the whole, I can see that I only have a repetition of these compounds. There's nothing different within here. Therefore, it is still a pure substance. There's only one thing here. It's just a compound rather than a singular element. That's basically the gist of our entire lesson here. So a compound is a substance made out of two or more different elements that are chemically combined or bonded together. So oxygen is a pure substance because it is made out of only one element. Distilled water is a pure substance, again, because it is made out of only one compound. Just water molecules would be there. So how can we test for compounds? So elements are a pure substance that cannot be broken down into simpler substance in our typical lab. Compounds, however, are made out of two or more elements, and they can be broken down into simpler substances by decomposition. So we can put them through a decomposition reaction. And typically, a decomposition reaction can be achieved by heating something or using electricity. So again, if we were in the lab together, we would do the decomposition of water experiment. So take a look at this video, watch it, and then we're going to answer some of the questions together next. Okay, I will link this on our course website for you. All right. So what was happening in the experiment after you've watched the video? So what test did they use for hydrogen gas? Well, if you watched, he tested twice, and he talked about both the glowing splint and the pop test. So for hydrogen gas, we've used the pop test. So we insert a lit splint, which is just like a coffee stirrer or a small piece of wood that has been lit on fire at the end. What we'll do is we'll take that, we will insert that splint into a test tube that we think has hydrogen gas. If it makes a popping noise, we will confirm that it must have contained hydrogen gas. What makes the pop? Well, hydrogen gas is very explosive, very flammable. So the pop is just a very small scale explosion, which is great and nice and safe to do in a classroom. On a larger scale, you could look up the Hindenburg blimp disaster. It was obviously a blimp filled with hydrogen gas because at the time, that's what they knew would float. It's lighter than air. And it unfortunately caught fire and there was a ginormous explosion. So hydrogen gas, the pop test is what we would use. Okay, oxygen gas. For oxygen gas, we use the glowing splint test. The glowing splint test is where we have our test tube where we think we have oxygen in it. We'll take our splint and we will light it on fire, quickly blow it out, and then insert it into the test tube. If once this is in the test tube, it relights itself, lights back on fire, we know that oxygen is present. Oxygen is required for a flame. We had heat, we had something to burn, and we had oxygen, so it's all great news for relighting that flame. How could you tell what gas was in each test tube just by looking? So just by looking, we had 2 test tubes right next to one another. And in these test tubes, gases started to collect, and it pushed the water downwards. I think the measurements he had were 7.8 mils, 7.7, 7.8, and about 3.8 mils. 3.8 times 2 is 7.8. So this one had twice as much gas as this test tube did. Now, if we looked at the formula for water, water has twice as many hydrogens as oxygens. Therefore, on this side, we have hydrogen gas, and in this side, we have our oxygen gas, just based on the ratio of hydrogen to oxygen within our compound. All right, based on this experiment, is water an element or a compound? Well, we know it's a compound just looking at it, but experimentally, if it was an element, nothing would have happened. We would have just passed electricity through, and our test tubes would have stayed full of water. There would have been no gas. So because we had a result, because something happened in our experiment, we know that water is a compound. What would happen if you switch the wires on the battery terminals? So let's say in this one, we had this electrode here, and it was connected to a battery this way. Okay, so if I were to switch the experiment where I have 2 test tubes and this battery I'm going to put this way, well, on the positive side of the battery, which is this side, we had hydrogen gas produced before. So on the positive side of the battery, we should expect hydrogen gas to be produced over here. And on the negative side of our battery, we would expect our oxygen gas to be produced. Hydrogen gas, we get twice as much. So we should look something like this in the end. So our experiment will still give us the same result of twice as much hydrogen gas as oxygen gas. However, our test tubes will be switched. Okay, it will look backwards. That's all. A little bit of practice for you guys to get a little bit more comfortable with the material here before our assignment at the end of the chapter.